simpler one that's also visual is this tree. Okay, so this is a tree fractal. And I'm going to change the parameters a bit here, but it's not super obvious what's going on. But every time it reaches a branch, it's going to split two ways. So this tree basically has a formula that says it's going to go, it starts out with the distance, which is about 100 units. When it reaches a certain percentage of that, it branches, and it creates a right branch and a left branch, but it creates the right branch first. And then it goes a certain distance of that, and it creates another right branch. It goes all the way until it reaches a certain length. And then it goes back and creates the left branch. And then it goes back to that fork and creates another right branch, another left branch, another, and you can kind of see the pattern as it goes. But you end up with this really interesting tree pattern. So I can play around with some of these things. Like if I increase the angle that it splits off at. Let's also slow that turtle way down so we can see what we're doing here. Okay, so now you can see the angle is increased, so the splits are a little bit more pronounced. But you can see it does the right-hand branch all the way to the smallest, and then it backs off to the next. And that's a pattern because it's doing the same thing each time it does this. It's just doing it based on previous information. So as we look at this code, here is the draw branch function. And this creates the whole tree, but it takes the turtle, which is the object that's drawing it, and the branch length. And it starts out with a branch length of 100. And it says, if the branch length is greater than 5, go forward for that length. So go forward 100, and then turn to the right. So split off at whatever the angle is. And then look what it does. It calls draw branch. So it takes this with a new branch length that's decreased by whatever the factor is. So it's 80% of the original or 70% of the original. And it calls this again. It says, if it does this, and you can see it just keeps drawing. That's why when we start this, it draws all of the right-hand branches first. Watch what it does. It comes up, it goes all the way to the right, and then it goes back and does the left. So it is going inside, recursion, 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 and then it comes back out a little bit. And so that is a really interesting pattern. But you can see it just keeps calling it draw branch. And if once it finishes, if the branch length gets to less than 5 or equal to 5, then it comes back out. So each time it recurses, it goes in here, in here, in here, and then it comes back out, and then it does the left branch. And then it calls itself again. Okay, so it's always, it draws the right, then the left, then the right, then the left, always getting down to the smallest possible level as quickly as possible.